Hey everyone, how are you guys? I hope you guys are doing extremely well. Today is 3rd August 2023 and the day today is Thursday. I don't know for how many days I've been recording videos. Maybe it's day 13th or day 12th, I don't remember actually. I'll put that in title so you can see that from there. So as I had said in my previous video that today I'll be discussing some more problems on searching algorithms and so yeah, let's start. But before jumping on to that, let me clarify one thing, that the problems which I'll be discussing are not very hard or very difficult. They are very easy, and these problems are very necessary, and these necessary to solve, and this will help you to build concept and to think logically on how to use the searching algorithms in questions. So let's start with our first problem. So what our first problem says is, we are given a list of n minus 1 element and which are in range from 1 to n. There are no duplicates in the array. One of the integer is missing, so we have to find the missing element. So as soon as you see this question, the first approach would come into your mind, that is the brute force approach, that we would run two loops and we will simply check if any elements is missing or not. So we would return that element, which is basically the linear search algorithm. So in this case, we know that if we are applying linear search algorithm, then what is happening is the time complexity is very high. That is, the time complexity is big of n square. So we need to reduce the time complexity. So what is the solution? Is this solution I had already discussed yesterday. So the best solution to this problem is, we could take the XOR of the numbers. So XOR the values, if we take the XOR the values, then what would happen is, like, if you are taking XOR of the numbers, then all the numbers will cancel will cancel each other, and then we can find the missing element. So the time complexity of this approach would be big of n. And what would be the space complexity of this approach? The space complexity of this approach would be constant space, because we are not creating any extra array or something like that. So the space complexity will be constant. Now let's talk about our second problem. So yeah, our second problem is missing values. So what the problem says is, we are given an array and we have to find the maximum and minimum value in the array, and we also need to find the range of minimum and maximum that are absent in the array. So first, anyone could think of the brute force approach, that is traverse the whole array and find the minimum and maximum value, then find the values from minimum to maximum in the array, and in this way the term complexity will be big of n square. So this is the basic rule which we could apply in all the algorithms, and it would take big of n square, and we know that big of n square is a lot of time, and we can't rely on this brute force approach for our task, for our completion of task. So what we could do is, let's discuss a more optimized solution. So what we could do is, we could use hash table in this question. So as I had already discussed, what is a hash table? A hash table is something like where we have key value pairs. So in this problem also we could use a hash table. So what we can do is, we can traverse the array and insert its element in this hash table. Also in this single traversal, we can find the smallest and largest value in the array. Now we will find that if the values between minimum and maximum are present in the hash table, if such values are not present, then we would print those values. So what would be the time complexity of this problem? The time complexity of this algorithm would be big of n. And what would be the space complexity? Since we are using hash table, so we are taking extra space. The space would be equivalent to the space required by the previous array. So this space complexity would also be big of n. So I hope this approach was clear to you. Now let's talk about one more problem. So what our next problem says is, the name of our next problem is odd count element. So what our problem says is, we are given an array in which all the elements appear even number of times. Like suppose we are given an array of 1 to 5. So 1 would appear two times, or 4 times, or 6 times, or 8 times. So all the elements would appear even number of times. None of the elements would appear odd number of times, and there is only one element which is appearing odd number of times. So we have to find the element which is appearing odd number of times. So what we could do is, in this solution, we could simply first anyone would think of using a hash table. So what we could do is, we could insert all the elements if not present in the hash table, and we would track as key, and we would track their frequencies as value. Suppose of the first element is 2, so we would add 2 in the hash table. The second element is 3, so the value of 2 will be 1. The second element is 3, so value of 3 will be 1. Suppose again I come across 2, So again we come across 2, so I will update the value of 2 as 2. So in this way I will keep updating all the values, and at the end if I find that any element has the odd number of it has its value as odd number, so I would simply return that element, and I could know that this element is appearing odd number of times. So this is one approach. What is the other approach? The other approach, so what is the problem with this approach? The problem with this approach is although it's taking big of n time, it's not taking big of n square time, but it's also taking big of n extra space, the space which is equivalent to the array, and we don't want to use extra space, we want to optimize this solution. So what we could do is, in this case, we would XOR all the elements in the array. Suppose 2 XOR 2, so we already know that 2 XOR 2 would cancel each other, so 3 XOR 3 would cancel each other. So any element which is appearing even number of times, if you take XOR of all these elements, then all those elements would cancel each other, and any number which is appearing odd number of times would be remaining element from the array. So we could simply get that element if we XOR all the numbers. So finally we will get the number which we are searching. So the time complexity of this algorithm would be big of n, and the space complexity would be constant. It is not requiring any extra space. Now let's talk about one more problem. This problem is similar to the problem which we have discussed right now. So what this problem says is, the name of the previous problem was odd counting element, and the name of this problem is odd count elements. So what this problem says is, we are given an array in which all the elements appear even number of times except 2. In the previous question only one element was appearing odd number of times, but in this question 2 elements are appearing odd number of times. So we have to find the elements which are appearing odd number of time, and it is given that we have to use big of n time complexity and big of 1 space complexity. So since we are given that we have to use big of n time complexity, so what would be the approach that what are the approach that can come to our mind? If it is given big of n time complexity, so we already know that we can't apply linear search in this algorithm. We can't apply linear search algorithm in this problem. That is, we can't use 2 nested loops in this problem, because it's already given that we have to use big of n time complexity. And what are the approaches, what is the algorithm which we can use? So in your mind you can think of hash table, like we would count the frequencies of all the elements, and then we would return the element which is appearing odd number of times, odd number of times. So we could use hash table. So let's read the question further. The question further says is, and it should also take big of 1 space complexity. So now we can't use hash table, because hash table take big of n space complexity also, but we can't use hash table because it's given that we have to we have to solve the problem in constant space. So what we could do is, I have discussed an approach in the previous problem also. We could XOR all the elements in the array. So what would be the solution step? Since the space complexity is required constant, so we can't use hash table. We know that when we XOR all the elements of an array, then even number of the elements which are appearing even number of times would cancel each other. So we have the sum of 2 values which we are searching for. So what we could do is, we would XOR all the elements of the array, and then we would take the sum of all the elements of this array. So in this way, we already know that only two elements would be remaining. These 2 elements are the elements which are appearing odd number of times. So we could sum these elements, and after that what we would do is, if we can divide the array elements into 2 groups such that these 2 values go in different groups, then XOR the values in these groups, then we can get these values separately. So as shown in this algorithm below, right mode set bit is used to separate these 2 elements. So I hope this was also clear. Now let's talk about one more problem. So what is the name of this problem? The name of this problem is sum distinct. So what this problem says is, we are given an array of size n, and the elements of the array may be repeated, but we need to find the sum of distinct elements of this array. If there is some value repeated continuously, then they should be added once. So I hope this problem was clear. So what we could do is, we could sort the input array. Duplicate values will come adjacent to each other. Now we would create a sum variable and add only those array which is not equal to its next value. So first understand what the problem says is, the problem is telling that there are n number of elements in this array, and some array are repeating. So we have to take there are 3 ones in this array, like 1 is appearing 3 times, but when I am calculating the sum of the array, then I will only consider 1 times. So how I can do that? I would do, like, first I will sort the array. So in that way, like, all the 1s would come in one place, all the 2s, all the 3s would come at one place, and likewise. So the array would be sorted, and then what I will do is, I will take the 1 only one time, I will check, like I will run the loop, and if I is equals to I plus 1, then I will only consider I. Again, if I is equal to I plus 1, then I will only consider I, and if I is not equal to I plus 1, then I will take sum of I and I plus 1. So in this way I will take sum of all the elements, and the time complexity of this algorithm would be n log n, and the space complexity would be constant n log n. Why? Because sorting takes n log n time. So in this way we could like takes the sum of the non-duplicate elements. Let's move on to one more question. So what this question, the name of this question is two elements whose sum is closest to 0. So we have given an array of unsorted elements. What we have to do is we have to find two such elements whose sum is closest to 0. Suppose the array contains 10, 11, 23 and minus 10. So if I say like 11 and minus 10, so 11 minus 10 is 1, which is closest to 0, but one element is more closer to 0, that is 10 and minus 10. If we take sum of both the elements, then 10 and minus 10 is equals to 0. So in this way we have to find which are the two elements which is equivalent to 0. So how we would solve this question? First, there will be a brute force approach. Brute force approach is similar as we have discussed in all our problems, which will take big of n square time complexity. We would run two loops, one nested loops, one inside another, and we would like traverse all the elements, and we would take sum of all the like sum of all the two elements, like sum of first element with all the other elements, sum of second element with all the elements, third element with all the elements are coming after that, fourth element with all the elements after that, and after that I will compare all the elements and see which elements is closer to 0, equivalent to 0, and I will return those two elements which the sum of which two elements was equal to this result. So what would be the time complexity of this algorithm? The time complexity of this algorithm would be big of n square. And what would be the space complexity of this algorithm? The space complexity of this algorithm is constant because I am not using any extra space. Now the time complexity is very large, it's taking big of n square. So what would be a more better approach? So the more better approach would be two pointer solution. So what we would do is we would first sort the array. So when we would sort the array, all the elements which is the smaller elements would come first, and the larger elements would come at the end. Now what we would do is we would take two variables, that is first variable and start variable and end variable. The start variable will point at the beginning of the array, and the end variable will point at the end of the array. Now we will take sum of the first element of the array and with the last element of the array, and if the sum is equal to 0, then we have the solution. If the sum is less than 0, then we will increase the first element, and if the sum is greater than 0, then we would decrease the second element, and we repeat the process until we get the desired pair, or we get first is greater than equals to second. If we get the desired pair, then we would return this pair, and this pair is our answer. So I hope this approach was clear, this solution was clear. Now let's move on to one more question. So what this problem says is we have to find pair in an array. So what is this? The name of this question is find pair in an array. So what this problem says is we are given an array of n numbers. We have to find two elements such that their sum is equal to value. So suppose we have given a array of some integers, and we are given a value k. So we have to find two numbers such that their sum is equivalent to the value k. So what would be the solution? First you can think of the brute force solution. We will take first element and take the sum of all the elements if its value if the sum of the first element is equivalent to any other element. If the sum of first element with any other element in the array is equals to k, then I will simply return that, or else I will traverse through the whole array and see if the sum of any two elements is equivalent to the array k. Now this is taking big of n square time complexity, as you already know. So what would be the better approach? So the better approach would be sorting. So what we can do is we would first sort all the elements of the array, take two variables, first and second. Variable first would be at the starting index, and the variable second would be at the end index, and we would compute the sum of first and the last index, first element and the last element, and if the sum is equal to the desired value, then we have the solution, and if the sum is less than the desired value, then we would increment the first, and if the sum is greater than the desired value, then we would decrement the second, and in this way we would get our solution, and we will repeat the above process till we get our desired pair, or we get first is greater than equal to second. This question is very similar to the previous question that I had discussed. So what would be the time complexity of this problem? The time complexity of this problem will be big of n log n, because you already know that sorting in any algorithm takes big of n log n time complexity, and single scan takes big O of n time complexity, and we know that n log n is greater than n, so the time complexity of this problem will be big O of n log n. And what will the space complexity? The space complexity will be constant, because we are not creating any extra array, or we are not creating any extra hash table or something like that for this solution. Now let's talk about one more approach, and this is the best approach amongst all. So what we could do is we could use a hash table in this approach. So what we can do is, using hash table we can create the track of the element that we have already seen, and we can find the pair in just one scan. For each element, insert the value in the hash table. Let's say current value is like ARR of I, like the first value is ARR of I, and if the value minus ARR of I, if the key value minus this the first element is equal to then any element which is already present in the hash table, then I will return that element and the element already present in the hash table. And if that is not present, then we would see the next element. So let me explain this one more time. I would first keep all the elements which is present in the array in my hash table. So this would take big O of n time complexity, and I will subtract the first element from the key that is given to us. Suppose the first element is 5 and the key that is given to us is 16. So the key which is given to us is 11. So what I will do is I will subtract 5 from 11, and then I will see if what is my result. My result is 6. Then I will see if 6 is available in my hash table or not. If 6 is not available, then we would move forward. Now suppose our next element is 3. Now we would see that 11 minus 3. What is 11 minus 3? 8. Now I will check if 8 is present in my hash table or not. If 8 is present, then my answer would be 8 and 3. Now suppose 8 is present in my array, so I will simply return 8 and 3. What would the time complexity of this problem? The time complexity of this problem is big O of n, and the time complexity of the previous problems was big O of n log n, and this problem is big O of n, but it is also requiring extra space for storing all the elements in the hash table. The extra space of this is big O of n, because you already have discussed many times that creating hash table requires big O of n space complexity. So I hope this was clear. We also give more preference to time complexity than space complexity. We always try to keep time complexity less than the space complexity. So I hope these questions were clear. Let's discuss one more problem. So what this problem says is, we have to find difference in pair. We have given an array of positive integers. We have to find a pair whose absolute value of So I hope all these problems which I had discussed today was clear to you. In the next video I will discuss some more good problems tomorrow, and I think that would be the last video of the problems in searching algorithms. If the problems are left, then I would record one more video in the same topic, or else I would move further or I'll try to explain or record video on some different topic. So I hope all this was clear till now. Thank you so much everyone. Bye bye.